Hello everyone. This video is regarding the Peterson's solution for the critical section problem in the operating system. So let me present the slides. The slide is regarding the Peterson solution. But before understanding Peterson's solution, you should know what is the problem that this solution is solving. Like, why are we calling it even a solution? It solves a major problem which is known as the critical section problem. You can read the definition from the slide here. I'll explain the critical section problem using some kind of pseudocode. Yeah, I think you can see the pseudocode in the Vim terminal here. I'll just a second. I'll minimize this window so that you guys can easily see. Yeah, I think I should minimize this window too. Yeah, so here, as you can see, there is a function named p. P is doing is nothing is just doing the here is a variable, integer variable I. P is just incrementing it. First P is reading it, then incrementing it, and then writing it. I am believing that you guys must know about what is context switching. So yeah, let's say that first of all there are two processes, P1 and P2. P1 called the function P and it read the value. Let's say this is assigned as 10 and P1 read the value 10 and it went to context switching, right? I think and incremented it to 11 and then it went to context switching. Then P2 came. When P2 came, it decided to read it as we are not performed the write operation yet, so the value assigned to P is sorry, the value assigned to I is still 10, so it will read the value 10 and after that it will increment it to 11 and will perform the write operation. And after when the context when the IO operation or any kind of operation for which the context switching of P1 process took place, then after that P1 came back and saw that after incrementing the value and the value of I is 11 and it will perform the write operation. So here the thing that will occur is that we can easily see that both the processes have printed the output as the 11 only, but uh, applying a very basic common sense thing, we can understand that after one process has done the increment, the other process has to increment that incremented value which has been written by the first process. So critical section is a situation where the output of the shared function depends on the order of execution. What if P1 executed first and after that P2 have executed? Then the values must be looking like this, like first one is 11 and the other one is 12. So this is the critical section problem. So a critical section problem has some criteria. First one is mutual exclusion. Mutual exclusion means one process should use the resource at a time. No more than one processes are allowed here to use. Progress means like the only that process should access the the resource which actually needs it. There should be no restriction that you have to know one process left the use function, so you have to use it. There is no boundation like that. Another one is bounded wait. So there should be a limit of time a process should be allowed to enter critical section. Like P1 is accessing the P function, have accessed the P function about hundreds of time, and P2 didn't even got a chance, so it will be an invalid thing. So yeah, this is called as bounded wait. So there are three criteria to solve a critical section problem: mutual exclusion, progress, and bounded wait. So yeah, now we will be looking at the Peterson solution. You can read the definitions from here. So yeah, importance of the critical section in operating system. You can easily read these things. So overview of Peterson's solution. Peterson's solution is you know is a savior. as we for two process synchronization. For multiple process, we got things like semaphore, which are helpful to solve, the multiple process a critical section problem which is caused due to multiple processes. And Peterson solution is a definite solution for two processes, to synchronize two processes in a critical section situation. So we have the Boolean variable thing which is used to solve, but there is no progress in that. Also, we have to keep in mind that the progress should not create a deadlock situation. And second one was the Boolean array thing, which was implementing mutual exclusion very well, but while implementing progress, we can easily see that while the context switching thing was happening, so the deadlock situation was created over there. So yeah, we will be seeing the pseudocode for the Peterson solution. So for this, we have a flag array variable. You can say it as an Boolean array. Yeah. So I think I should minimize this first. Yeah. Now I think you guys can see the pseudocode. Ignore my wallpaper. So yeah, here we have two processes, P1 and another process, P2. We have these variables as Boolean flag and another variable as turn. Turn is a Boolean variable, as here we are using only two processes, so 0 and 1 are enough to indicate the one and another process. So yeah, while 1 means while this condition is true. So this is the common thing in both the pseudocodes for P1 and P2. So yeah, first the process P0, first the process P1, for which the flag of 0 is assigned. I think you guys know that the indexing in arrays are done from 0 to n. So yeah, flag of 0 is assigned to process 1 and flag of 0 is assigned to process 2. So first the process 1 says that my flag is true. It has raised his hand, so that I am interested in going. But in the second line, it has given chance to for your information, that the variable turn, whenever it is 1, then it is pointing towards P1, and whenever it is 1, it is pointing towards P2, and whenever it is 0, it is pointing towards P1. So keep this thing in mind, same as array indexing thing. So yeah, it has given a turn 1. Turn 1 means it has given turn to process 2, that in case you want to go first, I am giving you a chance. As a elder brother, I am giving you a chance. Go inside the process, enjoy the critical section, and then you will come back. So yeah, here in while loop we are checking the situation, that either the turn is true, if the turn is true and flag is 1. So as you know, in AND operation, if one of the thing is false, then the operation turns into the operation cancels out, it gives negative value. So yeah, here also, while turn equal to 1, so yeah, we can see that we are the only one who have given the turn equal to 1, but flag of 1, here flag of, I think I should do it turn by turn. Yeah, right now the flag of 1 is true, and the flag of 0 is true, and flag of 1 is false. So here flag of 1 is false, so this situation turned into a false situation. So as you can see, I have added the semicolons here, so that you can understand that the loop is getting finished here. It is a trap situation. If both the situations got true, then the trap is open for P1 will be trapped here, and it won't be allowed to use the critical section thing. So yeah, where I totally forgot. Yeah, so the P1 process got inside the critical section as one of the situation, which is flag of 1 is false. So it got into the critical section, did his work whatsoever the process wanted to do, and then came out of the critical section, did flag of 0 as false, that my work is done, I am not at all now interested to go into the critical section. So it did it as false. and came out of the remainder section. Here all the things, and same goes for this process too. I have written both the scenarios for both the processes. If someone gets confused in, in boolean variable or flag thing, so you can easily parse the code once, and you will understand that what are the things going on here. So yeah, uh, here when mutual exclusion is totally there, if the turn is yes, if the both the things are yes, like we have given the turn, if uh, p2 is interested in going, it will raise its flag as giving the flag boolean array as true, so it will block p1 and it can easily go inside p2. So yeah, so to into the process, into the critical section. So here we can easily see that mutual exclusion is taking place. Another thing is that bounded wait, there is no bounded wait here, as the process who is interested, showing its interest even after the turn, a turn is given to another process. So the process who is interested will only be allowed to go inside the critical section, rather than the bounded flow, that I have the p1 came out of critical section, then it is responsibility of p2 to go inside the critical section. No, there is nothing restricted here over going into the critical section. So yeah, no, neither bounded wait nor progress nor mutual exclusion is here. This process is many a times asked in our college university exams. Also, there is a bit modified version of this solution, which is Decker's solution. You can also read it from some blog or something, and I'll add this pseudo code to the link in the description, so can you can easily see the code from the GitHub repo. And that's all. Sorry, I was not able to show much about the presentation, as I tried to explain about the things in the pseudocode format. So but yeah, thank you, and please like the video.